So, good morning, everyone. My name is Romulo Camillo, and I'm from Technical Marketing for SK Hynix. And I'm here to present our product roadmap, our SSD product roadmap, and also touch base on our collaboration with HPE. So, thank you for joining us today, and I'm glad you could join us. So today I'm going to be covering our latest PCIe Gen4 SSD, and I'm going to walk you through on some of the features and also the compelling design that we managed to port into this drive. Legal disclaimer, because this content contains some copyright materials and they're also subject to change. So for today's topic presentation, I'm going to be covering who is SK Hynix, a little bit of background on who SK Hynix is, and our SATA SSD, and also our NVMe SSD. So let's get started. Who is SK Hynix? Well, SK Hynix is the third largest semiconductor company in the world. So as far as the DRAM placement, we're second in global DRAM market. So the products are comprised of the DRAM, NAND flash memory that's used for SSDs as well as for smart devices. And also we have MCPs, sensors for your cameras. So most of although the bulk of our products is mainly on DRAM, so we're pretty active as far as like engaging and enabling the DRAM from DDR1 to all the way up to DDR5. So we have that expertise. So as far as placement is concerned, we're third from Intel and Samsung. On the SSD capability, so even though we have the raw NAND, we also have this capability to build and design our own SSDs. So we design our own ASIC. So we're vertically integrated. So we own the BOM from top to bottom. So we design our own SoC or the SSD controller. We develop our firmware, our FTL, and all the intricacies that come with managing the flash. We also have our testing facility both here in the States and also in Korea. So, and on top of that, we have a host of partners that we work with to do some interop testing and also early testing on our products to ensure that we don't have that our product is already matured and we don't have any corner case bugs that could escape to the customers. So as you'll see later, we're already on our fourth product for SATA and also our third endeavor for PCIe SSDs. On the HPE collaboration, we are pretty much one of the major supplier for DRAM for HPE, not only on the DRAM side for enterprise, but we're also supplying them with memory for client devices. And also we're working with HPE and enabling the next DDR, which is DDR5. So not only on we're engaged with on the memory side, but we're expanding that collaboration to now include our SSDs. That's SATA SSDs and NVMe SSDs. And then we're also working with HPE to enable some orthogonal technologies in the storage, like NVMe over Fabric, computational SSD, and also the next SSD that will be utilizing the next memory media or the storage class memory. So let me go through over our SK Hynix SSD, SATA SSD. So back in 2016, that's when we started engaging with HPE with our first SATA drive, which was the SE5010, and that was followed by the SE4011. That's what I have here, which was launched back in 2018. So what's so compelling about the SE4011 is with the previous product, which is the SE5010, that was using a 2D NAND. The SE4011 was the first drive to use the 3D NAND. So our 3D NAND basically resulted into better performance and higher endurance, and also higher capacity, obviously, right? The drive is used ideally for caching and OLTP, and so basically it gives you that performance without the added premium cost associated with enterprise SSD. And that's one thing that we excel in, is designing a high performance SSD without the premium or the power that's associated with it. So we're able to control the power budgeting and power envelope. So the SE5110 is the follow-on product to the SE4010. So this will be the first drive that's going to be using our 128-layer vertical NAND. So 128-layer NAND was the first vertical NAND that was introduced or announced in the market last year. So SK hynix was the first one to announce that. So we have that capability already as far as like integrating this NAND technology into our SSD. So the SE5110, which is a read intensive SATA drive, is going to be using this NAND, which should be able to give you a higher capacity. And also, since we're updated the controller, then you should be able to see some drastic performance increase. In terms of roadmap and scheduling, so the SE4011, which was launched back in 2018, that's going to be followed by SE5031, which is already MP this year. And later this year, the SE5110, which is the V6 with our 28-layer NAND, it will be available in the market. So that's one thing that should be looking forward to. Going to our PCIe SSD, our PE8000 is our Gen4. So what we're seeing in the market now is with PCIe Gen4 coming online, and we're seeing this ramp in the PCIe Gen4 adoption. And why is that? Because the ecosystem is already ready. So the Ice Lakes or the Intel platforms with PCIe Gen4 are already starting to get deployed or in the market, and also with AMD supporting PCIe Gen4, it only makes sense that the devices supporting Gen4, like the SSD, should see some massive adoption in the space. Also, with QLC coming online, that's also another tiering that will be cost effective for flash. So now that before you have that gap between 3D and legacy spinning disk, now you're able to reduce that gap between 3D and spinning disk by having that tier in between, which is our QLC NAND. So not only will reduce the premium for flash, it's pretty much we're hoping that that's going to be the inflection point for legacy and flash. And also EDSFF is the new form factor that's gaining traction in the hyperscale. This is going to be the M.2 form factor replacement as that we're seeing in the market. The EDSFF gives you that capability that was not found in the M.2, like hot plug, and also the capacity, increased capacity with EDSFF. So why PCIe Gen4? So as mentioned in my previous slide, I mean, PCIe Gen4 is double the bandwidth, so increased performance. So in terms of cloud infrastructure, you're able to service more VMs, and also with increased performance, now you're able to reduce your TCO, because now you're able to have so many VMs in one bare metal box. So what's so compelling about PCIe Gen4 PE8000? Well, it's we're positioning this product for data center. So not only it's Gen4 interface, but it, the power is so optimized that we're able to bring the performance that's only offered or can only be found in 16-channel PCIe Gen4 SSD. Ours is more like we're positioning it as a data center SATA replacement. So we're able to achieve 1.1 million IOPS, and we're able to support capacities of up to 7.68 terabyte. So we're bringing in this product as best in class in terms of IOPS per watt. So with NAND technology, we introduced our 4D NAND last year. So we are SK hynix pioneered this what we call the 4D NAND. So what is so compelling about the 4D NAND, even though the 3D NAND is already impressive as a technology, we managed to further enhance the feature of for 3D NAND to 4D NAND. So what it is basically moving that periphery circuitry on the bottom of the vertical NAND flash or the memory cells. So the periphery circuitry is what's needed for that functionality of the memory cells. So as you scale, as you increase the size of the die to a bigger NAND die, or more vertical or more layers of the memory cells, you also have to increase the periphery circuitry around it. But by moving that circuitry under the memory cell, then we're able to reduce the size of the chips or the die. So which results into more die per wafer. And also by doing that, we were able to reduce cost and manufacturing, and also the performance. We were able to improve the performance overall. So the 3D 4D NAND 128 layer today with V6 is going to be followed by the 172 layer V7 in the coming years. As far as performance, we characterize our PE8000 to side-by-side performance with PCIe Gen4 that's available out there, 16-channel PCIe Gen4. So what's so impressive about our drive is we were able to outperform the PCIe Gen4 16-channel from competitor, but we came in with a lower power envelope, so meaning we're able to deliver better performance with less power. So that translates to better reduced TCO and also reduce OpEx from a cloud perspective. In terms of PCIe Gen4 roadmap and schedule, PE6000 is our current PCIe SSD, which is based on Gen3 PCIe Express, and it's using a V4 72-layer 3D NAND. That's going to be followed by our PE8000, which is going to be available later this year. Two swim lanes are available on the PE8000, which is our read intensive, and also our mixed workload, which is our PE8030. It's going to use the V5 96 layer 512 gigabit die 4D NAND from SK hynix. In terms of drives that have been qualified at HPE, I have here listed the drives that completed qualification at HPE. We have the SE4000, the SE5000 SATA drives, and that's going to be followed by the SE5110, which I mentioned earlier in the slide. So SE5110 is going to be a read-intensive SATA drive. That's going to be the first drive using a 128-layer 4D NAND from SK hynix. The PE6000 PCIe Gen3 NVMe SSD also completed the qualification at HPE, and that's being followed by PE8000, which is going to be available later this year. So we should be able to complete that qual as well. In terms of form factor, we're offering them in U.2, U.3, and M.2 form factors. So what's so nice about the U.2, U.3? So our drives are able to support backplanes of either U.2 or U.3 without having to have a separate SKU. So we're able to adjust on the fly as far as signaling is concerned. So that's one feature that we brag about on our U.2 NVMe SSDs. As far as what we're doing in the industry, where SK hynix is actively engaged in defining the next SSD interface and next form factor. So we're part of the NVMe technical work group, JEDEC, PCIe, and also SNIA. In NVMe, we're advocate for ZNX. So the next ZNS, the definition that you're going to find in the SSD. So what's so good about the ZNS? So as you scale the capacity of the NVMe SSD, there's a challenge of managing that capacity. So with ZNS, you're able to isolate or better define multiple namespaces and manage that namespaces depending on the endurance that you want. So even if you're using a QLC on an NVMe SSD with ZNS, you're able to control that data placement and also the wear and tear of the NAND flash. It also gives you that performance because you're only writing in sequential. As far as the NAND technology is concerned, as I mentioned earlier, we're going to move from 128 layer to 172 layer and beyond. So you're going to see capacity of SSDs that's unheard of. So if you think 32 TB or 64 TB capacity on NVMe is already impressive, then expect to see some 128 TB in the future. As far as the form factor, we also have E1S and E1 long and E3 that were already part of our roadmap, and we're going to be including that in our product line going forward. So EDSFF, or the new form factor that's ramping, is going to be a replacement of M.2 eventually, because the EDSFF gives you that capacity and also that flexibility as far as the hot plug is concerned that you don't find in the M.2 form factor. So NVMe over Fabric is also one thing that we're also actively engaged in trying to enable. So we're working with a partner as far as optimizing our drives to better leverage that NVMe over Fabric specs. So not only will we be able to see greater adoption or increased adoption in SSD in a disaggregated fashion, but because since you're going to be reducing that latency in the network fabric. For computational SSD, that's also one thing that we're working on. So integrating the next storage class memory into more like a computational SSD. So now you're able to offload that management from that's being typically done by the root complex or the CPU down to the ASIC or the controller of the SSD. We're also going to port some features like PMR and CMB to be able to do some peer-to-peer between SSDs without having to go through the memory hierarchy of the management, the system or the root complex. So it's going to be a lot of exciting stuff that's coming online from SK hynix. So I encourage you to reach out and feel free to work with us as far as tackling all the challenges that you may see that's forthcoming. So thank you for joining this presentation, and hopefully you gain some insightful information from SK hynix. You can check out our website at www.skhynix.com for additional information on our products. Thank you.